Well, look who's here to learn about design patterns in Salesforce. Well, you're in the right place. In this video, I'll be talking about the Builder design pattern. It's a creational design pattern made popular by the Gang of Four design pattern book published way back in ancient times, the mid-90s. I'll be walking you through practical use cases for implementing the Builder, and along the way, I will of course show you how to implement the pattern, but more importantly, why you'd want to use it in the first place, and maybe why you'd want to avoid it at times. So we'll take a look at TestDataFactories as our practical example, and I'll show you some of the pros and cons along the way. It always starts simple, right? When you first write an Apex test, you do the simple and the obvious thing. You create a test method, you create whatever data you want to create, insert it into the database, and then eventually assert some scenario. And that works fine, and that works well in most scenarios until you start noticing some repetition. The repetition becomes obvious, right? Soon you have the same setup code everywhere. So we're setting up accounts in test class 1, test class 2, test class 3, so on and so forth. And that's just account. We're doing the same thing with contacts, opportunities, contracts, leads, you name it. But you're a good developer and you want to keep your code dry. So you refactor it to reduce that code duplication. In your first attempt to do a refactor, you create a TestDataFactory. You extract that repetition into another class, so you can call this class instead of repeating the code inside the methods. So you make a class called TestDataFactory, you create a method in there called createAccount, and you create your account. You can do the same thing with contact, lead, so on and so forth. You're feeling pretty good about yourself at this point. You don't have code duplication as much, you have a central place for all your test data, and it's relatively easy to maintain at this point. But over time, your tests start needing some variations. Some tests need specific industries on the account. Others need specific annual revenue. Some need a billing address, some don't. And others need phone numbers. So what do? You make more methods, you add more parameters, and your methods begin to telescope. On that last method, there's 5 parameters. They're all strings. How do you know which one's which? What happens if you pass them in the wrong order? What's going to happen? Maybe you try to get organized in a different way and create specific methods instead. So you have a create account with industry, with revenue, with billing city, with industry and revenue, whatever other permutation and combination you can think of and that you need. But this will blow up on you. We're really not going to be having a good time in this code base. It's going to be a nightmare to maintain. Your code base is in trouble, your tech lead puts you in timeout, and they explain to you that telescoping methods, like the ones we saw, make it hard to keep track of multiple parameters. It's easy to accidentally pass arguments in the wrong order. I'm guilty of it. I've done it plenty of times. And they add this thing called cognitive complexity to the code base, meaning that as I'm writing code, I have to pause and think very explicitly about how to call something and remember something very specific about the code instead of it being very intentional or obvious to someone reading or writing code. So your tech lead asks you to use the builder pattern next time. So that means code that went from looking like this can now look like this with the builder. The idea here is that you can chain methods to specify only what you need, and each line reveals intent very clearly. So with the first example there, I'd have to guess that, okay, the first parameter might be the name, the second parameter might be the industry, I think the third parameter is the billing city. I don't know what the last one is. Maybe it's the revenue, maybe it's the number of employees. I'd have to go open up the TestDataFactory class and the createAccount method and actually look. With the builder, we're revealing that intent a lot more clearly. We can see that Camp Apex is the name of the account, the industry is tech, the city is NYC, and the annual revenue is 100. And if we didn't want city, we just wouldn't call the with city method. If we didn't want with annual revenue, we just wouldn't call that method. Whereas in the first example, we would have to pass in null or create another method that would exclude that parameter to begin with. So what is a builder? It's a special class that you create yourself that knows how to construct complex objects step by step. So the builder class knows how to build an object. It specializes in doing that. It also holds the object that's being constructed. And I'll show you what that means here in a second. It gives you additional configurations or methods to configure each part of that object that it specializes in. And when it's done, it returns the finished object to you. Your test code in this example tells the builder what to build, right? It's the director in this scenario. It creates a new builder, it calls those configuration methods based on what it needs, and it gets back that final object so it can go process it however it needs to. So let me show you how to make one. Step 1, we need to create the builder class. The builder, like I said, holds that local object that's being constructed. It'll set the fields on this record and return it when it's done. Optionally, we can define a constructor to default some required fields. So on account, we know name is always required, so we can have the constructor just set a default name for now. That way, if the test class wants a name, it could set it itself, but if it doesn't, it'll always be guaranteed to have back a valid account because this constructor ran. Step 2, we'll add our first builder method to the builder. So in this example, we created a new method called withIndustry. We'll pass in the industry, and the method will set the industry field on that local account record based on the parameter that was passed in. But instead of returning that local S object, what we're going to do instead is return this instance of the account builder. And this is what allows us to chain these methods together because we're always returning back an instance of the class. The last thing that we need at a minimum here is to add a build method. The build method is going to actually return that finished internal object. So it's not going to return an instance of the class anymore. And this is how we get that local object out of the builder and signal that the chaining is now done. That might seem a little abstract until we see the actual result or what that calling code would look like in a potential test class. So there it is. In the first step, the account builder is initialized. The local object account inside that account builder has been created. It's been set to a default name because the constructor ran. Then the local object account was updated again by us calling withIndustry. Once that method is done running, that same instance of the account builder is returned back so we can continue to calling methods on that object. The last step, the local object account is returned and stored in new account. And there's no limit to how many methods you can add. So in this example, I've added another method with annual revenue, another one called with field where I can pass in any arbitrary S object field and any arbitrary object and have that set more dynamically. And I can even define predefined subtypes. So if I have a type of account, like for example, a free trial account, and I know those accounts will always have a specific type, they will always have a specific industry, annual revenue, and description, I don't need to create methods for each of those. I can create one method that helps me encapsulate or represent that specific type and preset all the fields. That way in my test, if I want to stand up a free trial customer account, I can create a new account using this builder, call the as free trial customer if I want, and any other combination of methods in here. So here's the cool thing. This solves some of those problems that we saw earlier with the TestDataFactory. You no longer have to guess what each parameter does, and you only specify what matters to you. In that example above, what were we even setting to null? You wouldn't know without actually opening up the method and looking at it. We eliminate any potential risks of misordering parameters with the builder. And again, we call only what we need. Here's an example of what a test method would look like with and without a builder. Both these examples are setting up the exact same data, but leveraging the builder, one is a lot easier to read than the other. So the question is, which test would you rather maintain? I know my answer. And replacing a TestDataFactory, that's just one use case of a builder. We can also, for example, build JSON for an API call. We can build complex SQL statements instead of manipulating strings directly. And we can even build all our S objects with it. It doesn't have to be limited to just a test scenario context. And that's what the Apex Domain Builder framework shows off as well. So when should you use these builders? They're great for when you have objects with many fields that you sometimes care about. It's great if you have different field combinations per test. You have complex Salesforce objects. Think about your accounts, your opportunities, your leads. You really are probably better off skipping it if you have simple objects that very rarely vary or have simple initializations. They're just not complex. Or if you have one-off test scenarios that you'll never really repeat. As a rule of thumb, if you find yourself creating multiple factory methods for the same object type or passing in lots of nulls to constructors or other methods, consider using a builder. Well, now you know a design pattern. Let me know if this helped, and there's more available on campapex.org. Thanks for watching.